I saw Eliza Schlesinger in St. Louis. It was a good show. I had fun. No one cares. That's fine. What questions do you have? Before we continue on doing the law of cosine stuff. We'll do a few examples of law of cosines today. Pardon me. Take your quiz at the end of the hour. Like I mentioned last time, 2 problems. One just a normal, just solve triangle. One will be an application problem. So not a huge surprise. It was just over law of sines. Okay. We'll do some application problems with law of cosines Wednesday. Wrap up whatever we need to do, hand out review on Friday, and then your test is Monday. All right. Well, let's look at this particular example where it asks you to solve the triangle. Notice this one should be a huge clue that you don't want to use law of sines because you have no angles at all, right? With your law of sines, any equation that you set up has sine of one angle and sine of another angle on the other side of the equation. You can't possibly have 2 of them unknown and use that to solve for anything, right? So this one should be a huge clue that you can't use law of sines on. Okay. So we need to use law of cosines to help us figure out one of the angles first. Now I would encourage you to always find the angle across from the biggest side first. Okay? The reason why I do that is because say you use law of cosines to find one of the smaller angles and then decide to switch over to law of sines to find another angle because the formula is a little bit smaller, right? The problem is that if you then use law of sines to find the bigger angle and it turns out to be obtuse, if you do inverse sine in your calculator, you won't get the obtuse angle, you'll get the acute angle instead. You'll get the wrong angle. Okay. So if you're using law of cosines to find an angle first, find it across from the biggest side. Okay? So in this case, let's find beta first, since b is the biggest. Okay? Remember, there are no ambiguous cases with law of cosines, right? There's only one triangle, assuming you have a triangle, there's only one triangle that satisfies it. Okay? So you can't have a law of sines thing, you have to check ambiguity if you're using law of cosines first. All right. So in this case, we will rearrange the law of cosines formula to have b on one side and beta on the other. Doesn't matter what order you put A, B, and C in. Oops, I'm sorry. Doesn't matter what order you put A, B, and C in. Law of cosines works so long as the side that you have squared on the one side of the equation, its angle opposite it is on, oops, that's not sine, that's cosine of beta. Sorry. It's hard using law of cosines if I wrote the word sine down, right? Sorry about that. I looked back and like, hey, that's not what I wanted to write. Okay. Try that again. The side that you have on the left-hand side of the equation, its angle opposite is the one that you have on the right-hand side. Then the other 2 sides make up the rest of the formula. Okay? Again, it doesn't matter the order as long as you have those things across from each other. Notice that, like I mentioned before, notice again, as I mentioned before, that looks like what? Pythagorean theorem, right? Okay. And again, if your angle is a right angle, cosine of that will be 0, and it is the Pythagorean theorem. So your law of cosines is basically just an extension of your Pythagorean theorem to non-right triangles. Okay. Anyway, pardon me. Our B here is 17, A is 11, C is 10. So at this point, it's just a matter of plugging those things into the formula. So we need to get cosine beta all by itself. Let's see. 17 squared is 289. 11 squared is 121. 10 squared is 100. Oh, 11 times 10 is 110. 2 times that is 220. So you get a negative 220 in the denominator. Right, we need to subtract the 11 squared and the 10 squared over and then divide by the coefficient on the cosine of beta. What do we get? Pardon me. 68. 68 over 220, negative. If I did my arithmetic right. All right. Obviously, hopefully it's obvious. We'll need to do the inverse cosine of both sides to get beta by itself. All right. But before I even do that, since cosine is negative, is this angle going to be between 0 and 90 or between 90 and 180? 90 and 180, right? It's in quadrant 2. It has to be in quadrant 2, so it has to be an obtuse angle, right? Okay. So do your inverse cosine. I didn't bother reducing the fraction because this is definitely a calculator active problem. What angle do you get? 108.00. 0.00? Okay. We'll leave it then as 108. Now that we found beta, you could find alpha or you could find gamma using law of cosines. I typically find it easier just to use law of sines because it's a smaller formula, right? But you can use law of cosines if you want. I personally find it easier to use law of sines. So I'll find alpha first just because. So if I do sine of alpha over 11, what should I set that equal to? Good. Use your beta that you just found, right? Again, I don't care if you round when you write your answers on your page, but remember, if you're using an answer that you've calculated before, keep your digits in your calculator. Make copious use of that previous answer button, or store it as a variable, or write down a bunch of digits on your paper and type them all back in again, okay? If you round a calculated answer and then do a new answer around again, it's going to compound rounding errors. Not that that's horribly important in a math class because we're just doing things with computations. It might be horribly important if you're, I don't know, building a rocket. You might want to make sure things are accurate. All right, so multiply both sides by 11 and then do the inverse sine. And what do you get?
37.98.
Okay. And then finally, to get gamma, how do we do that? Good. Yeah. Add them up and subtract it from 180. And what did you get for that?
34.
Cool. What questions do you have on that process? Is this okay? All right. So again, with law of cosines, you're going to use it if you have two sides and an included angle, that side angle side idea, or you're going to use it when you have all three sides given to you, that side idea. Again, if you're able to use the law of cosines to figure out the triangle, there's only one. There is no ambiguous case. The only ambiguous case that comes up is if your first step in the law of sines is to solve for an angle. Then you have to check for a second triangle. That's the only ambiguous case we have. Okay. let's look at this next example. Which of our theorems does this one involve? Well, I've got two sides and included angle. Right? Got two sides and an included angle. So this one must be a law of cosines idea. So what are you going to solve for first then?
Oh, side B.
Side B, right? I'm given the angle opposite from B and the other two sides, so I'm going to find B first. Again, does not matter the order of the letters, just the one side of your equation is what has the two sides and an included angle, right? So I have A and C on the right-hand side, so beta is in the cosine. If you had A and B on the right-hand side, gamma would be your cosine. If you had B and C on the right-hand side, alpha would be your cosine.
I think it should be.
Oh, for heaven's sake. Good grief. Thank you. It's a Monday. Thank you. Appreciate that. All right. So again, we are given A and C and beta. So all of that's going to be on the right-hand side. The B squared is on the left. That leaves. Listen to what I say. I don't look at what I write, apparently, today. All right. So the A is 110. The C is 138. I about wrote sine again. That's why I paused for a second. So you just need to do all the arithmetic on that right-hand side and take the square root. What do we get for B?
About 84.97.
Say it again, I'm sorry. 184?
84.
Oh, 84.97, sorry. Well, it's just a matter of getting it in your calculator, right? So we still need to figure out alpha. We still need to figure out gamma. Again, my personal preference is if I want to find an angle usable as sines, just because the formula is smaller, right? However, I have to be careful, just like I mentioned in the previous one. I do not have an ambiguous case in the law of cosines. There's only one triangle, right? Before it was, if I used the law of cosines to find a different angle, and then tried to use my law of sines to find beta, I would have got the wrong answer to start with, unless I was careful. Okay? Same idea here. If I want to use the law of sines, I don't want to use it to try to find the biggest angle, because that's the ambiguous case, right? I don't know if it's acute or obtuse. So if you use the law of sines at this point, I want to use it to find alpha rather than gamma. Okay? I want to use it to find the smallest one because I know the biggest side is across from C. I just don't know if it's acute or obtuse. However, you can only have one obtuse angle, right? So I know the biggest angle is across from C. So if I find the angle across from A first, it has to be acute. Does that make sense? Okay. So when I'm trying to use my law of sines to find an angle, I'm really trying to force it to be, I find the acute angle, I don't have to worry about trying to check a supplement. So let's do alpha first versus beta. Okay. All right, so sine of alpha over 110 will be sine of beta, which is 38 over 84.97. Same idea again. That value is a calculated value, so keep those digits in your calculator. Don't type back in 84.97 for your next step because unless it's 84.97.000, something with a lot of zeros. Keep those digits in there. What do we need to do? Multiply by 110 and take the inverse sign. What did you get for that alpha? Now we got something quiet for alpha.
I don't have rounding here, but I got 52.85.
Say again?
52.85.
52.85? Okay. Sounds good to me. I don't have a calculator, so I don't have a calculator. I mean, I've got my phone, but I don't have a calculator with me. Okay. So then gamma again, we would find by adding the other two up and subtracting it from 180. What do you get when you do that? And again, the numbers match up for which one's the biggest side, which one's the second middle side, and which one's the smallest side. As far as the angles go. Any question on the process at all? Again, you can use the law of cosines in the second step to find the angle if you want. Right? I could set up the equation. Now that you found B, you could find alpha or gamma using the law of cosines if you'd like. I just think the formula is longer, and then I have more work to do and better chance of making an arithmetic error. Right? I think the law of sines is a smaller formula, and I don't have as much chance of typing something in wrong. That's why I use the law of sines. But you can absolutely use the law of sines in your second step if you want to. Okay. I only typically use it unless I have to, because it's just a longer formula. Not that I don't know it, it's just a longer formula. Questions on that at all? Let's look at this last one real quick because it's a special case. This one looks like your side, right? Again, same idea that I mentioned before. If I weren't paying attention, there's something that you could do this one really fast. But if I weren't paying attention, which angle would you try to solve for first? C, the gamma, right? One across from there. So you would have 30 squared equals 20 squared plus 9 squared minus 20 times, 2 times 20 times 9 cosine of gamma. $30 squared is 900, 20 squared is 400, 9 squared is 81. 9 times 20 is 180, times another 2 will be 360. So again, I just subtracted over and then divided. By the way, I don't need to do all this work, and I'll go back in a second why I don't have to do all of this. 900 minus 400 gives you 500, minus the 81 will give you what? Negative 419. So I get negative 419 over 360 equals cosine of gamma. What's wrong with that equation? It's bigger than, the number we have is less than negative 1, right? It's below negative 1. And we know cosine of an angle always has to be in between negative 1 and 1, right? So this really is no triangle. And I could see it from here, right? If you put this in your calculator, you're going to get an error. Okay, if you try to do the inverse cosine of that, even if you don't think about it. What's wrong? Well, if I take A and add it to B, we get 29. The third side's longer. You cannot have the third side of a triangle be longer than the sum of the other two sides. Think about it. What's the shortest distance between 2 points? Well, the shortest distance between 2 points is always a straight line, right? Well, if I have go to here and be 20, and then put another 9 on the end, my 30 is longer. How could I possibly make a triangle out of that, right? Because if I try to push this up, those are going to get closer together, right? For a third side, right? Okay. So there's not an ambiguous case for the law of cosines. However, there is a case where you might not get a triangle, and that's if you're given 3 sides, but the sum of 2 of them is less than a third. The third side's too long. So this one is no triangle. So you can still get a no triangle, but it's not really an ambiguous case for the law of cosines. It's that the farthest apart your vertices can get was be 29, and now you've got a 30. Does that make sense? Okay. All right. So there's no triangle here. I get it from here too, by the way. This tells you there's no triangle as well. But the simpler way to do it is A plus B is 29, which is less than the 30, which is C. Does that make sense? Any questions on doing these with the law of cosines at all? Like I said, we'll do some application problems next time. I think there's a few more problems here that you can practice on in the packet as well. But I do want to give you time to go ahead and do your quiz.